Hello, welcome to Apricot 2021. My name is Melody and I will be your MC for today. Thank you for joining us and I hope you've had a good break. We are now kicking off APNIC's Plenary. So this is the APNIC track in the Apricot conference. Now for this plenary, the topic is on routing security. RPKI and routing security continues to gain momentum across the internet operations community with high-profile ROV deployments globally and ROA adoption in the APNIC region almost doubling to 51% in 12 months. If you joined APOPs yesterday, the speakers has already emphasized on this. But is this enough to secure routing and provisioning now and in the future? So this session will explore current challenges and the work in progress towards the future use of RPKI. Now, before I begin, just a little bit of housekeeping. The first one, of course, is our code of conduct. You can easily find it in the Apricot website or in the Zoom chat, which our very awesome moderator, Dave, has shared for you. Number two, if you have any questions or comments during this session, use the Q&A button that you can find at the bottom of your screen, or we haven't used this much, the raise your hand button. This works just like lining up at the microphone during an in-person event. So if you would like to use your audio microphone to ask a question, click the raise your hand button on your Zoom controls, and you will join the queue. And from our end, we will be enabling your microphone so you can ask your questions verbally. So I hope we use this a little bit more because I find that a little bit more interesting rather than just reading out your questions. Apart from that, we do have the Zoom chat box. Now, those are just for general comments or any questions you might have that's conference related. So only keep the Zoom chat for general comments, and for any questions for the speakers, use the Q&A button or raise your hand. That's all from me now. It is my pleasure to now introduce to you our first speaker, the one and only APNIC Chief Scientist, Jeff Houston. Welcome, Jeff, and please proceed.
Thanks, and good morning, good afternoon, and everything else. The one and only. God, if there are more of me, that really is time to worry. Yes, my name's Jeff Houston. I'm the Chief Scientist at APNIC. And today I'd like to talk about futures, where this heads as distinct from what's going on right now. So I actually want to talk about the other part of the puzzle with routing security. Because ROA validation, origination, actually isn't enough. It's only half the story. Here's a little example network. AS1's connected to AS2, to AS3, to AS4, to AS5. And there's someone doing nasty stuff, AS666. Now, AS666 wants to divert traffic that would normally go to AS1, 192.0.2.24. Now, he's not on the path. The path is 4 to 3 to 2 to 1. So how does AS666 become evil? Well, he can't advertise more specifics easily because most folk filter on /25s and not upwards. So he can't advertise more specifics. But what he can do is fake the path. So what he announces to AS4 is an assertion that he can reach AS1 directly, as if there was a link directly between AS666 and AS1. This gets to AS4, and AS4 goes, well, that's a really short path. It's shorter than the other one I've got. I'll announce it to AS5. Now, AS5 is doing route origination validation. And what it's found is that AS1's been a very good little network, well done, and has produced a ROA for this address that it is originating, saying, I'm AS1, I'm 192.0.2.24, and I give permission for AS1 to originate this route. So AS5, which was originally receiving a long path with the correct origin AS, is now receiving via AS4 a shorter path with the correct origin AS. And oddly enough, both AS4 and AS5 have now been duped. Rower validation doesn't help, because if you can lie in the path, anything's possible. Now, what is an AS path? That's a good question, actually. If you look at the original specification of BGP, an AS path serves two purposes. BGP is a distance vector routing algorithm. It works by rumor mill. I tell you my best path, you tell your neighbors your best paths, etc. So if something disappears, you just withdraw, your neighbor withdraws, etc. But let's go back to I tell you my best path, you tell your neighbors the best path, and so on. Oddly enough, if you form a loop, it doesn't stop. It just doesn't stop. How do you make it stop? Well, if anyone remembers RIP, God, there's a word that no one's used in anger for a very long time. You'll remember that RIP had a maximum count. So every time a route got propagated, one was added. So I send a route to you, one becomes two. You send it to your peers, two becomes three, etc. If it ever hit the number 16, there was a loop. Whether it was a loop or not didn't matter. RIP vector 16, metric of drop. But BGP is a little better than that. It actually records the identity of every neighbor, every AS that handled that route. So I'm AS1, you're AS2. I mark the route with myself, AS1, and when I pass it to you, it's marked 1. When you get this route and you pass it to your neighbors, you add your stamp, AS2, AS1. If it ever gets back to you, you'll see yourself already, and you'll go, no matter how this happens, it's a loop. So that's the first thing, loop detection. The other issue is that the way BGP prefers different routes is that there's no universally agreed metric in the inter-AS space. So BGP does this really simply. The shorter the AS path, the better the route. So AS path is route selection. Those are the only two things that BGP guaranteed about the AS path. Notice I didn't say forwarding path. I didn't say AS paths to be passed over when delivering the packet, because that's not the purpose of the AS path. Lots of people think it is, but it's loop detection and route selection. Now, lots of folk muck around in paths. AS path prepending. If you've been listening to these kinds of talks in BGP, many folk have talked about prepending over the decades. It's a well-known technique to de-prefer a path. Here are two paths. I don't want you to use this path. So I'll add some extra versions of my own AS in there. AS1, 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 AS2. It makes it less preferred. Also, if I don't want you to receive my route, one way I can do this is to synthesize your AS in the path already. So when I put it in the path that I advertise to my neighbors, it's as if you've already seen it. So when your neighbors try to deliver you that route, you say, oh, I've already seen it, and drop it. AS path poisoning. Been used a lot, actually, and it's very, very useful. So we manipulate the AS path for all kinds of uses. And most of the time, with route origin validation, it doesn't matter. As long as you keep the original AS, then you can do anything you want, good and bad. Now, how do we protect the AS path to stop people manipulating it? Well, you take an observation that is generally true, but not always. That when a route propagates through the network and each network adds its own AS, you can think of the AS path as this snail trail of where the object has been in propagating that route. Now, if I can get some kind of encryption across that path as it is built, then that path is now untamperable, untouchable. And this was the idea behind BGP Sec. Now, this is a bit of a mouthful of two sentences, but let's try it. Every eBGP speaker, router, is equipped with a private key. That key is associated with the local AS through RPKI and certified within the RPKI framework. When I pass an update to a neighbor, I take that path signature block, I add the AS of the neighbor I'm sending it to, and I sign all of this with my private key. So here's this AS1, AS2, AS3, AS4, AS5. And if you think about it, what's gone on is that AS1 has passed the route to AS2 and signed it. AS2 has passed it to AS3 and signed it. Similarly, AS3 to 4, AS4 to 5. Now, the beauty about that is you can't touch any of this without altering the validation. It's now sealed as a unit. This is cool. It's now tightly tied to origination. You can't play with the AS path anymore. That's great. But what if someone in the middle of that path isn't playing? You've only got partial deployment. Well, everything stops. So BGP Sec only works in islands. The islands can never be bridged together. That in itself is probably fatal. But there's more. Routers need to hold private keys and perform signing functions. Yeah, right. They could possibly do that, but sending out private keys to tens, hundreds, thousands of routers out there in your network is a brave act by anybody. Not normally done if we can possibly avoid it. But that's not even as good as bad as it gets. Let's go back and look at how many signatures were on that simple block. 1, 2, 3, 4. So what happens when I send you a full route set of close to 1 million routes, each with an average of 4 or 5 signatures attached? I'll come back next year and see if you've got the answer. Routers aren't very good at that kind of computationally expensive model. Somehow you've got to get rid of all that computation. But it's worse. There's still the problem that routing leaks are undetectable, because this is not policy correctness. It's only protocol correctness. Yes, no one mucked with BGP, but you might have mucked with, I sent provider routes to another provider. Oops, BGP Sec won't catch that. So all of those things say death. BGP Sec's never going to happen. Well, okay, that's not going to happen. Now what? Well, what if we just do nothing? And go, well, half is enough, right? Origin validation's good enough, right? Well, I don't think it is. Now, I think we'd all accept it's not enough, but there are differing views as to how much not enough is not enough. Some folk make the case that you can do a little bit with BGP peer lock, you can do some origin validation restrictions, you can make some plausible assumptions about your position in the AS routing hierarchy and who are tier ones and who aren't, to actually give you a decent set of AS filters that get rid of most synthetic routes. And the whole idea is to get a cheap way of converting not enough to be good enough. They could be right, but I personally disagree. I think a determined attacker is your worst nightmare. And if you're not good enough to get rid of a determined attacker through this approach, then the approach isn't really working that well. And I personally think that unless you can work the AS path into this structure, origin validation alone is about the equivalent of wearing, impermeable armor plating made of wet lettuce leaves. It's just not enough. So what's in between massive, difficult, confronting security of BGP Sec and do nothing, let's just wear the risk? Well, there was something about 17 years ago called Secure Origin Bgp, which talked about a concept of plausibility, that everyone just talked about their neighbors. So AS1 said, I'm connected to AS2. AS2 goes, I'm connected to 1 and 3, and so on. Now, interestingly, in our little hacking example, when AS666 sends an update to AS4 asserting connectivity to 1, AS1 is saying, nah, I'm not connected to 666. That's a lie. And so if everyone does this, it actually gives you a tight constraint on what's a lie. A lie actually has to follow the topology. And at some point, you can't tell the difference between a lie and truth. They're both viable routes. So SOBGP, very lightweight. It actually allows the same technique of off-router processing and detached filter management. And with a little bit of thought, you can actually do piecemeal partial validation. You can do islands. The beauty of it is that if I sign all my neighbors and say, I'm connected to all these other ASs, then if you lie about me, you have to include my neighbors. And if any of them are also doing the same, sign all neighbors, you have to include all their neighbors in the path. So in some ways, it's very, very hard to construct short paths once you get partial validation past a threshold. So it kind of works even if everyone isn't playing. But I can still leak. It's the same as BGP Sec. There's no idea of policy. So the good thing, validation and plausibility, which, by the way, path plausibility totally offends the security geeks. How dare you talk about approximations? Well, I am, okay? Let's just get over that and move on. And the whole issue is it's most effective when more people do it. But even when a few do it, it's effective for those people because it prevents you lying about their ASs. But this whole issue of policy is still a problem. Let's explore what policy means. Well, in the simple terms, don't lose money. So if you learn a route from a paying customer, you certainly advertise to other paying customers. They're paying you to promulgate their route, so you advertise it to all your peers and all your providers. Cool. Routes learned from peers. I pay them. Well, I'm not going to advertise it to my send to keep all peers, other peers, because that's not my problem. I'm not going to send it to my providers because that's free transit. So if I learn it from a peer, I'm only going to send it to a customer. And if I learn it from a provider, I am only going to send it to a customer as well. Same reasoning. So we can start to think about AS paths as almost like a hill. If you think of a customer as being at a lower level of altitude than the provider who sits at loftier heights, and when two folk do a peering arrangement, they're at the same altitude, then every AS path is a vector, and every valid vector climbs a hill and never a valley. So on the left, a valid path, customer to provider, peer to peer, provider to customer, provider to customer. What about the second case? Oddly enough, that's a leak. Customer to provider, provider to customer, provider again. I advertise it to a customer. The customer re-advertises my routes to another provider. Oops, bad idea. There's a valley. This is why we call it valley-free routing. But it's more than valleys. The third case is where I advertise it to a peer and the peer advertises it to a provider. Again, that's a leak. So what you're after is an AS path that has none or more customer providers uphill, just one or maybe none flat tops, a plateau, and none or maybe more downhills provided to customers. So let's have a look at this when I add AS6 and I start to talk about assumed customer-provider relationships. Then if I have a path that transits from AS3 to AS6 to AS4, that's a valley. And because it's a valley, if we're doing this marking, you can detect it. So let's put all of this together and come up with a rather clever hack that goes sparse AS neighborhoods, sparse SOBGP plus valley free. Every AS lists all its providers, not all of its neighbors, not even all its providers and peers, not its providers, peers and customers, just its providers. These folk are allowed to propagate routes that I pass them and nobody else. So it's an authority, a bit like a rower, but in this case, it's not signed by the prefix holder, it's signed by the AS, and it's listing everyone who's a provider. So if I get a path, then if everyone's doing this, I'll actually see that sequence. I'll get forward links, a plateau, and then some backward links. And in partial deployment, there are a number of rules that say, I'll see the same structure, but there are missing pieces where I don't know. And that's okay. So let's look at an example here. In my topology using ASPAs, there's customer provider links in this direction. And now if I get a route that passes through there, that's where the problem lies, that you see this valley that gets formed because provider customer is followed by customer provider. Oops. Now, like SOBGP and its neighborhoods, I like this for a number of reasons. It's extremely lightweight, no keys on routers, no crypto. Yay. It allows the entire AS neighborhood processing to actually happen off router. The same as ROAs, you can do the whole thing away from BGP if that's your dream. I think it's a nightmare, but if that's your dream, you can follow that dream. So you can do off-router processing, you can do detached filter management. So the entire router to RPKI machine to router protocol, you can use that as well, and allows for piecemeal adoption, the same as ROAs. And basically, again, most route leaks get detected as long as the usage ups. But if I'm advertising all my providers, you can't lie about me unless you lie about my providers too. So in some ways, there's an incentive for everyone who's an AS to stop being part of a lie by generating a list of their providers. So it's not perfect. It's not full validation. It's plausibility. But what you're trying to do now is limit the lie, not catch the lie, but limit the lie. Quite frankly, without path validation, none of this is going to fly in the long term. If the real effort of all of this thing is not just to stop fat finger problems, there are lots of ways of doing that, but to stop deliberate, sophisticated attack that is as good or better than your defense mechanisms. Folk who are as learned as you and as capable as you. How do you stop that? We need path protection. And in some ways, I think ASPA is a suitable compromise between feasibility and protection. There's a draft out there. At some point in the timescale of the IETF, if we all live that long, it will get published as an RFC. I wish it was going to be faster. These days, the IETF makes the ITU look quick. Saying a lot. The filtering operational model is yet to be defined. You can do it exactly the same as ROAs, use a processing engine with crypto, sends an update to an AS path filter maintained on the speaker, exactly the same as ROA validation, except you're speaking AS pairings. This can be done. Interestingly, you could probably also do it inside onboard processing in the router, because oddly enough, the processing is not intense. And if you can strip out the crypto somehow and put the crypto off board in the same way as SOBGP tried, I think we're actually almost there. So I'm really optimistic about this, and I wish Alexander Asimov and his crew at Curator Labs all the strength, because they're going to need it to get it through the IETF. But it seems to me to be the only way through the mess that we've created. Hopefully there's still a couple of seconds left for questions. I'll happily answer some and then hand it onward. Thank you.
Thank you, Jeff, for another great presentation. Now, while we wait for questions to be submitted via the Q&A button or by clicking the raise your hand button, I do have a question for you. So while we wait for a viable AS path validation implementation, what should folks do in addition to Origin validation?
Don't get your hopes up. Don't think you're protected. Use Internet Route Registry tools if that's your bent, because that offers some degree of policy validation. And just understand that you're still vulnerable to determined attack. There's no plan B here, Melody. This is a long-standing problem. And unfortunately, unless we protect the path, or until we protect the path, a capable attacker can do an awful lot of bad things, almost irrespective of most of the known defenses. We're just scrabbling around at the edges without a viable path protection mechanism. And that just seems to be frustrating to me. We're just not getting there. So I suppose the answer that there is no viable plan B should at least motivate some of you to go, I really, really want this. Oh, router vendor, why haven't you got it in my router already? Come on, I'm waiting. Where is it? Do something. That's the best I can offer.
Thank you, Jeff. Fingers crossed that RFC quickly happen. We do have one quick question from Aftab, so don't go away yet. So two questions from Aftab actually. Can we sunset BGP Sec so people don't ask about it every again? And the second part, we are at a very low level of ROA adoption, so let's not dismiss ROV to at least get rid of 4,000 mistakes made last.
So the first thing, let's sunset BGP Sec. God, it's so hard for the IETF to say we're wrong. I think it's a great idea and it should be, but that doesn't and will not make it so. I'm sure somewhere out there is someone who still has BGP Sec as a gleam in their eye. God knows why, but that's probably what they do. I'd be nice if it was sunsetted. You can't do path validation and expect everything to work either. ROA validation is critical, but it's not a protection that stands on its own. It's a two-part thing. And so in some ways, this is what we've done so far. Get some experience with crypto, understand the vulnerabilities, stop doing invalids. And we're now getting tools to understand who's doing this. Manage keys, integrate an entirely new aspect of activity into route management that you've never had to do before, and get comfortable. Because ASPAs is only a slight delta from a ROA. Instead of the prefix owner authorizing an AS, it's an AS holder authorizing providers. So in theory, the delta from ROAs to ROAs plus ASPAs is small. The real sort of jump is from doing nothing into putting crypto in routing objects. And you know, whether you do it as a ROA first step or ROA plus ASPA, that's the big delta. So I'm not dismissing ROAs as being, well, that was wasted effort. It's not, but it's not the entire effort. Don't do it and think it's done. Thank you.
Thanks, Jeff. Can you answer this in 30 seconds? Are there any...
No, there are open source implementations of BGP in a number of languages. Feel challenged. Write an open source implement, add to the open source. Do it yourself.
There you go, Patrick. I hope that answers your question. All right, last one, Jeff, before I have to let you go. Could all tier 0 have a better picture of the whole network structure?
Generally, no. BGP is good that all of us have a pretty entire picture of most of the network structure already. Look at BGP AS paths and some of the big route collectors, and the entire internet is exposed to you. This is not a secret to tier 0s. BGP tells everybody everything. That's the nature of the protocol.
Awesome. Thank you so much for your time, Jeff. Now, we do have some questions in the Q&A box. If you're sticking around, would you be able to type your answers to them?
Some homework. Cool. Thanks.
Thank you so much,
Bye,
Jeff.
all. Thank you.
Now we're going to move on to our next speaker. Next, we have Frederick Horsback. He is AWS Senior Technical Business Developer. So over to you, Frederick.
Thank you very much. Yeah, I'm starting my presentation here. Always technology, right? Hopefully this should work. All right, does that look fine?
Looks good, go ahead.
All right. Yeah, good morning to the APNIC conference here from a very early Stockholm, Sweden. My name is Frederick Horsback. I'm a senior technical business developer for IP Interconnect, or just BGP guy for short, for Amazon Web Services. I'm here to speak a little bit about routing security, present and the future, not so much the past, to kind of fit into the topic. So the table of contents today is the AWS and RPKI, where we are today, a little bit of bring your own IP in RPKI, and also where we're going with RPKI in general. So if we start with where we are today, I think it's a good primer to kind of understand where we are in our process and our thought, train of thoughts. For the full context, there is a pretty good blog post, I would say, that I wrote back in January on kind of the details on a lot of things we're doing. But in short, I would like to cover 4 big things. So we are dropping RPKI invalids in 100% of our internet edge border. This is about 220 global POPs and a couple of thousands of edge routers. So it's a pretty significant deployment. Today, we have signed more than 98% of our announced IP space. This is still today, as far as I know, the biggest kind of batch of covered IP space in the world. So it's the equivalent of, I believe, 250,000/24s. The 2 remaining percent is typically in Brazil and in Africa for us. And there is some things, you know, where with lack of APIs, because we cannot do this by hand, right? Like this is not something we can maintain by having people signing ROAS. So we need functional APIs from the RIR or the provider at the time to be able to kind of maintain ROAS. We also have something internally, what we would like to call like an IP vending machine, not very unlike how RIR works. So all of our internal customers, they apply for allocations. They need a good reason for getting allocations. They need to make sure that it's used appropriately, that they have coverage and everything like that. So like an internal customer could be EC2, for example, or the CDN or a global accelerator service or anything like that. Whenever they do an allocation, we make sure that we do a ROA renewal, and we make sure that we create them for them, that we maintain them, monitor them, and make sure that we have them covered in all of our anti-hijack tools and these kind of things. We also have very, very short expiry dates on our ROAS. We regenerate typically every 6 weeks, and we have at least 1 week of overlap to make sure that we are never without ROAS, basically. We also have both the RPKI OV and ROA creation is a Severity 1 service for us. So this is something that is monitored with on-call teams, with NOCs. We have follow the sun rotations. There will be a lot of alarms if something breaks. And this is kind of like a learning process for us, since we have been seeing, you know, outages at the RIR level, for example. And that causes a lot of people on our side to wake up, which is also why some RIRs have been getting angry calls from us, like, hey, something's broken. So this is kind of where we're at today. So let's look forward, right? So bring your own IP is what I'm mainly here to talk about. And bring your own IP is, you know, if you want to bring your IP addresses to the AWS services, it's a quite common thing, and it's getting more and more common. As we all know, IP resources, especially IPv4, is expensive, and we have to buy them, and we have to charge for them to the customers. And if the customer happen to have IP space of their own that they would like to bring along to the cloud, we are more than happy to support this. So today, Bring Your Own IP is supported in RIPE, ARIN, and APNIC service regions. We do not support it today in LACNIC or APNIC, but that is definitely on the radar. So the first thing we like to do is to make sure that the network is validated to announce your IP space. So a customer needs to create a ROA, so that we have no other way of doing this than use RPKI, really. So the first thing the customer has to do is to create a ROA, so that AS16509 and 1460108, which is our 2 primary ASNs, is allowed to announce the IP space. So this is something the customer needs to do. Of course, they also need to maintain IRR objects, but the ROA is kind of where that triggers the process for us. After that, we need to, the other step of the process is to figure out which account should this IP space go into, which is kind of the problem we have been facing for quite some time, is like, how do we do the second round of authentication? So today we do it with a bit of a hacky method. You have probably seen it at some point, where you see RDAP records that has, you know, long X509 certificates in them. But this is the best way we could figure out at the time to kind of make this process good, right? So today, what people need to do is that they do a self-signed X509 certificate, and they put it in the RDAP record of the IP space at hand, or the route object at hand. Then they create a specific authorization mesh in a certain format that we have pre-designed, for example, with account number. Like a customer could have 15 different AWS accounts, right? Depending on departments or what they're trying to do. So it needs the account number, it needs some dates, it needs the actual IP address, of course, and it needs an encrypted string. And this signed message gets then uploaded into the AWS console, and then we can kind of tie those things together, where we look at the RDAP record and we use the authorization message in the console to kind of make sure that, all right, seems to be the account where we need to bind this IP resource to. So this is a bit of a hacky method, but it kind of works. But we are looking to improve this process. So this is, if you do this with a console, this is how it looks like, right? So you, with OpenSSL, you generate a key, you create a message. It's not very simple, right? It's not very convenient either for people. So this is why we're looking forward to something else where we can utilize the RPKI system fully for bring your own IP. So we want to basically replace the process at some point. So there's two things that we are looking to that I believe is very interesting. So I believe George is going to talk a little bit about this later, but it's going to be RTA, of course, and quite recently, kind of like a version to it called RC. They are extremely similar in concepts. Even RC copied most of the things from RTA. RC might appear a little bit simpler because of multi-signatory, and I believe George will address this too after this. It could help with adoption and more running code, but I mean, in general, we're just interested in whatever works, right? So our idea of how this should operate for customers instead is that the customer logs into our AWS portal, into their account. They have an account hash of some sort presented to them. This hash can get moved into the RIR RPKI control panel, the RIPE or the APNIC or ARIN control panel, and then get a signed message back. This signed message can then get uploaded into the AWS console, and everything is fine and dandy. And we understand that, yes, this account should have these IP resources in them. So that's kind of how our train of thoughts has been going around this, on how this would make it easier for customers to kind of onboard, bring their own IP space in a faster way. So we are following the work in CyderOps very carefully. We are happy to see, comments and anyone that has opinion in this, and that we're taking this work forward, right? So we think this is highly interesting work in both of these drafts. And we're looking forward to be able to implement this on our side as well, as soon as we have something that actually becomes an RFC and implementable. All right, there's other things where we're going, right? So this is not the only thing we're doing in terms of RPKI. We are deeply kind of engaged into this community, and we would like to see more things happening. So one of the things that we would definitely do is to look into distributed RPKI solutions. Like the hosted RPKI we do today with RRs is good, but I think we can do better. So I think 2021, if 2020 was the year of kind of people signing ROAs and starting to do origin validation at large scale, we think at least that we will see a lot more distributed RPKI solutions next year, or this year actually, and we will definitely be one of them. So this is kind of the top of our radar. We would like to see improvement of the bring your own IP processes for customers using, for example, RC RTA. We are also working, and I maybe some people in this room has already faced us here, and that we're trying to reach out to basically every single network that has RPKI invalids. Given that we have a pretty deep peering footprint, we typically have an AS path of less than 2 to most networks in the world. Which means that we see a lot of invalids. Like at any given point, we're dropping a lot of invalids on our network. So we have been compiling the biggest offenders is the wrong word maybe, but the ones that send us the most invalids, and kind of try to engage them in a strategic way. And there's definitely a few of them in the APNIC region. So we are working together with you guys to kind of help you figure out what's wrong. Because a lot of the things we see is, of course, traffic engineering, failed traffic engineering. And it's important that people understand that this traffic engineering is not working because we are dropping those more specific invalids that you're sending to us. We're also super interested in community projects such as Manners. So Manners is, for example, something we have been engaging with quite a lot recently. I saw actually yesterday there was a new blog post from Manners that the Cloud and CDN working group has been working quite a lot here for a year on making kind of RPKI one of the core fundamentals of improving routing security. So we would like to bring some attention to that, and we're absolutely committed to continue with that to kind of improve on the process and help out the community to foster RPKI as one of the more important tools of better routing security. We're also interested to help RIRs, since we are in a RIR meeting, I guess, to improve where needed on features and operational stability for the ecosystem as a whole. Like most RIRs now, or every RIR has now transferred from being bookkeepers to actually running critical internet infrastructure, which I think is an important learning process that might require some more thoughts and processes to actually work. Big outages on the RPKI ecosystem is not good. So I think we as a community need to kind of work on that as a whole to get this solved. So I don't have anything more. I guess there's Q&A coming up, hopefully. Otherwise, I'm happy to hand it over to George.
Thanks, Frederick. Really good presentation. So just a reminder, guys, click the Q&A button if you would like to type in your questions or raise your hand so we can enable your microphone and you can speak directly to Frederick. So Frederick, people might be taking some time right now to submit their questions. Perhaps you could let us know, where are you joining us today?
Yeah, I'm joining from Stockholm, Sweden, right? So it's a very early start for me. It's pre-coffee time for me. So, so
thank you so much.
Thank you.
Thank you so much for joining us at such an early time. Now, I don't see any written questions submitted yet. And let's have a look if anyone has raised their hands. None so far. However, I have a written question already for you, Frederick. So really quickly, what was one of the key lessons learned in your RPKI ROV journey that might be useful to others planning to do the same?
All right. Yeah, that's a great question. So one of the things that took us the longest time, I guess, was to automate against the RIRs. Like all the APIs looks a bit differently and maybe not even present, right? So that was kind of one of the biggest blockers for us that consumed most of our time. The other thing on the OV side, right, was vendors, right, router vendors. Like how do we make sure they don't have bugs, right? Because most of the vendors here, they implemented RPKI maybe 10 years ago in the code, and then nobody used it. And this kind of show, right, when you dust off the old books and started to use these functions, like and then the operating system of the routers has evolved over 10 years. There is definitely things hiding behind the closets. So we have to see all of that. And hopefully most of that is fixed, or we think that most of this is fixed now. So now I think we're in a pretty stable state right now, but it took us quite some time to get there.
We do have a question as well from Anurag. Do you also use IRR in any manner like ASSETs for generating filters?
I'm trying to read the questions. Let's see. Oh, there. Yes, we are. I can't go into detail right now exactly how we use them, but yes, we use IRR data to generate filters. But how we kind of look at it is, of course, that RPKI will replace that as well eventually, right? So, for example, looking at these improvements on, for example, RRD4, I think we're very interested in, where RPKI ROA kind of drown out stale IRR objects. Yeah. I also see another question there from Phil Mawson. If you had complaints from users who could not access AWS because the route had an invalid ROA, and the answer to that is yes. We absolutely have people reach out, and the only solution to that is fix the ROA, right? Like we don't inject anything through Slurm or anything like that. So it's like, yeah, if you're in a invalid ROA, then fix it. Like we will not open the doors for you, right? So. And we were quite firm on that already from the get-go. Even on the planning stage when we started this 2 years ago, we were like, yeah, we will not do any exceptions, right? So hopefully we kind of made the internet a little bit better place because of that as well.
Thanks, Frederick. Wonderful presentation. Thank you so much for answering the questions. We will now move on to our next speaker. So thank you once again, Frederick, for getting up so early and joining us for Apricot. So we have our next speaker, who is none other than APNIC's product manager for the registry. We have George Michelson, or formerly known as GGM. George, the floor is yours.
Thank you, Melody. Are my slides coming through okay?
Yes, absolutely.
Hello, everyone. I wish they'd put me on first because this is a very pedestrian talk, and really you should have heard the other two people as the closing message because they had much more interesting and informative information. I'm going to give you a quick rundown on the current status of RPKI as a product, as a service operated in APNIC. So, we currently have somewhere around 25% of all our delegations, entities able to operate RPKI. About half the people who hold delegations work directly in APNIC, and about half of them operate through the NIR. And there's a bit of variation between them. It's actually slightly more direct membership. But nonetheless, if you're looking at the absolute numbers of people active in resource management in APNIC, there's about 20,000 of them, and somewhere around 25% of them currently are active in RPKI. So we're making ground, but we're a long way shy of the kind of scale of coverage that would let people talk about using this as a more fundamental precursor to deciding to move on what to do with invalids. Percentage of coverage, well, this has been done for this talk as the percentage of the delegated resource. Maximally aggregate the holdings, sort them by economy, and then compare that to the maximally aggregated prefixes that are in the rowers. This doesn't take any account of what is announced in BGP, so it's very likely to vary from other people's statements of what's visible in global routing. Right now, from APNIC space in V4, 20% of things that have been allocated or assigned are covered in a rower. In IPv6, it's actually a bit less, 15%. So again, this is still a very low number set against the kind of degree of coverage you would need to move to a much more aggressive use of RPKI to decide that things potentially unknown are not safe. I've done a quick breakdown for V4 and V6 by the 56 economies of our region. Now, the reason for this is that if you look at these numbers quickly, you'll see that in many of our economies, we actually have virtually complete coverage. So in Bhutan, or in Pakistan, or in Nepal, we have really astronomically high, really high numbers. These are communities where there's been active outreach, there's been social engagement, there's a small community of ISPs that meet and talk and collaborate, and they've been able to achieve a very high penetration by their economy. These are generally smaller economies. So if you look for the large powerhouses, the places that have the bulk of population in our footprint, India, for instance, that's only at 50%. It is nonetheless 50%, but it's not as high as 95, 96, 99%. Or Australia, 26 million people, we're on 28%. Indonesia, which is about 250 million people, is only on 18%. And China, as large as India, is only on 2%. And this distribution by population is effectively why we're seeing that the degree of coverage in our holdings in the APNIC region is so low, because the depth of address holdings in the larger economies aren't adequately represented in the coverage of the rowers. So the NIRs, 4 of APNIC's NIRs, CNIC, IDNIC, JPNIC, and TWNIC, are operating their own systems, self-hosted inside their own infrastructure, as children under APNIC. The other 3 NIRs, VNIC, IRIN, and KRNIC, are using the service in our portal to manage RPKI on behalf of their members. And the key takeaway here is all of the NIRs are able to supply coverage of rowers for their sub-account holders. Their membership in us can get rowers, but the degree of activity is very variable. So if you look again at this table at the bottom, you'll see that in Korea, it's a very, very low penetration, whereas India, that is not actually operating a self-hosted system, is at 50%. So the amount of rower service isn't necessarily a function of having it integrated into your local supplier, but it does have an impact on the ease, the utility of use. Who's using it? Well, on a daily basis, we see something like 1,000 discretely different ASNs reading the data from APNIC either over RRDP, that's a web protocol, or rsync. But they have actually diverged very slightly into two separate communities. The overlap is 1,009, but they aren't all using the same protocols all the time to fetch the data. Now, that count of ASNs isn't a good indication of who's calculating ROV and making routing forwarding decisions based on this information. Jeff is running an absolutely fascinating live experiment where he beacons up and down a prefix, and he beacons up and down the signing status of that prefix to have a lie, an invalid rower, or a valid rower. And he looks at the difference to see if he can see how people vary their BGP. And he's able to give a breakdown in regions and globally and by economy and by ASN. Really fascinating stuff. I definitely recommend you go and have a look. Self-hosting. APNIC is operating the protocol boundary for provisioning and allows people to operate their own RPKI inside their own infrastructure. And we now have 5 clients who are operating this apart from the 4 NIR. Jeff is one of them. That's how he's operating his beacon. Interestingly, the other 4 are all multi-homed. They are all existing visibly under more than one RIR. Now, this is really interesting because it means that we now have a protocol boundary, the provisioning protocol, that is completely consistent across all of the RIRs. This is something Frederick touched upon a little bit, that it's mechanistically really difficult for people that are dealing with address resources fetched from all the different registry agencies to have to deal with different interfaces to manage how those work. But in RPKI, it's one boundary and it's one system. And if you self-host, you can go to all of them, I believe now all of them, and request for delegation. And then inside one integrated management system, you have all your assets. It won't be one certificate. It's going to be 5 discretely different certificates or possibly more. But you do have all of your resources in one management framework. This, to me, is going to be the enabler of the emerging technology like RTA or RSC. Code's available for self-hosting. We sponsored the development of this in Krill. We worked with them to get this operating correctly under us. So RTA and RSC, as Frederick mentioned, these are classic detached signature models, and they're currently under discussion in side ROPs. I could make a case that they should be discussed in the ops area working group because they're not really necessarily directly about BGP. They're about the provisioning side. And it would make a lot of sense if we talked about this in the community of people who understand provisioning. That's not how it worked out. The thing is, we have 2 proposals on the table. RTA is the classic design, and it's a multi-signer model that APNIC came up with because we were conscious from the very beginning that people are likely to have more than one certificate over their assets, or that they will be constructing states where more than one individual entity needs to declare some aspect of the address holdings that are being worked on. So we deliberately designed a model that encompassed this. And this has been proposed and adopted in the working group. But to be brutally honest, the reaction in the community has been, this is very complicated. People don't like complicated. And an alternative model that is a much simpler single signer model called RSC has been proposed for adoption, and I think has had universal acceptance from the community. I believe it has now been adopted. Both of these mechanisms are essentially the same. They use the standard CMS primitives. Standard tooling in like OpenSSL can understand how to manipulate these. RTA, by design, doesn't actually expect that its signed object or even the detached signature lives in a repo. And we did this decision deliberately. We wanted to make sure that the provisioning process that might be done between a holder of an asset and someone that's going to announce it in the future remains private. Not everybody wants to make a public declaration of intent when they do provisioning. BGP, that's public. That's something that happens after You do a lot of configuration work with your provider as a customer. And we think there will be other business-to-business reasons that people want to keep this private. I can't say everything would be private because the certificates that lie over these objects may be visible, but the digital signature itself, the signed object, these don't have to be exposed. There's working code for both of these systems. There's code in NLNet, that's the stuff that I talked about earlier that we sponsored in Krill. There's code from APNIC. Job Snijders has worked on a system for RSC, and we actually modified our code base to support this as well. I believe that RTA and RSC are really good fits for self-hosted. And my reasoning is there are legal and structural reasons why some registries are reluctant to supply this class of service. They've looked at their operating liabilities providing signing services, and they put a really tight legal boundary around what you can and can't do with the certificate. And so coming to them and saying, hi, I've got 1,000,001 new objects I'd like you to add to your signing methodology, that's a headache. Self-hosting, that's not their problem. You've taken on board all of the process costs around deciding to use these keys to do your business. So I think this is a good fit because this model will work under any RIR. There is no impediment to operating either RSC or RTA in a self-hosted environment. So the main story that I will also be bringing to the routing security SIG is that we have been taking a long, hard look at the resilience of our RPKI systems. Fred made comments which I think are very true and real about the obligation of someone in our functional role, high in the tree of delegation service, operating a service. Previously, the things we did, they lay behind filter generation or they lay behind configuration systems. So if we were offline, it was a slightly lower impediment to what people did. Now, things that we're doing could appear in BGP within minutes of being committed by us. So we've been promoted from having a passive state against global routing into a much more active, visible effect on the integrity of global routing. And if we're going to have that functional obligation, we have to have a long, hard look at the resilience of our systems and how they're operated. So for this year, we're already undertaking a review of the certification practice statement. That's the public declaration of how we operate our service behind the production of the RPKI products. That's underway now, and it's going to be published in mid-year and will be available on our website and is actually minted as a URL in every single certificate we publish. It hasn't been revised for about 10 years, and we think from now on it's going to be a much more frequent production cycle to reflect community concerns there. We're doing some re-engineering of our RPKI platform to make it more robust and to scale it to meet future demand. Currently, we're able to run the complete cycle for those 2,500 members who are active adequately, but we'd like to make sure that as the volume rises and as the cycle time of changes in produced objects rises, that our software is capable of serving that load. So we have opportunities to improve parallelism and to speed up some basic code paths, but also to make the platform fundamentally more resilient. We're looking at different container technologies and different approaches to hardening that system. We're improving our systems monitoring. RPKI predates the adoption of Prometheus, Grafana, integrated monitoring systems. It's part of our Nagios framework, but we'd like to make sure that the systems monitoring is brought into the modern era. And we also intend extending this to have coverage of the NIR. It's very easy for us to say, well, we're APNIC and they're the NIR. That's not us. But the thing is, we are actually one collective whole, and we're going to have to be conscious of the availability and reliability of people who functionally are acting as agents in our information system. So our intention there is to do something that Job Snijders has commented on and publish more frequent statistics on service availability and issues of significance. We're also thinking about certificate transparency. I've got that noted later on. Also, we're looking in the longer term towards improvements in our publication framework. The AS0 system is already using a full cloud distribution framework, and we are able to show that for European operators like Fred, that can mean a reduction of 250 milliseconds in the RTT fetching the critical information. If you're using rsync, which is inherently a strictly serial fetch, that's a significant improvement in the send-receive cycle time. For web protocol, it's perhaps a little less beneficial, but nonetheless, we do see caching benefit for people using RRDP, and we want to bring that to the mainline RPKI. And we have paid a community benefit cost towards the development of features in Krill. This year, we're funding development of TA, trust anchor operation. It's really quite different to normal operating mode. You have to be the apex entity. You have nothing above you to tell you ground truth, and your operating cycle has to be done in a much more constrained environment. And HSM support. We know that at least one operator is quite interested in use of Krill, and the primary concern for using an HSM is to protect the business logic that secures your transactional exchanges over the protocol boundary with your upstream. It's not actually about protecting the keys of RPKI quite so much. They tend to be ephemeral, but your business keys really do need to be protected because they could be used to take the idea of an engagement between you and your upstream to another location. So we're aware there are options like cloud HSMs. We're looking at options like PKCS 11, but we were aware of an opportunity in Krill and we decided to fund that. For next year, we're looking at the additional hardening and redundancy to our own TA and publication points. We want to make sure that there's disparate routing paths so that we're not captive behind a single AS. We're looking at the certificate transparency process that Job Snyder suggested. This means that we'd be publishing an immutable log of the transactional changes in our root certificate and related objects. And we're thinking about whether we should make the oversight function of these public commitments a function of the routing security SIG. That would take us much closer to the model RIPE NCC have with oversight. So HSMs, if you have bought one of these machines, they're deliciously expensive and you're paying a large amount of money for a Linux host in a special rack mount box with red "it was broken open" seals on it. But the thing about these is they tend not to want you to do things like take the key and put it somewhere else. That's what an HSM says. I don't want to let you do that. So if you want to run a pair of HSMs in a relationship, you actually have to start from scratch. If you're operating your HSM in the FIPS mode, the highly secure mode, you probably can't get the key from it into the other thing you want to run. So, second thing, HSMs have fixed lifetimes. When you upgrade them, your supplier has a story that's very straightforward. I'll let you upgrade smoothly to the next generation. But if you don't take that option and I then sell you the grandparent, I won't guarantee you that you can move your keying material transparently through. It's kind of a bit of a trap, but the deal here is that we have an extremely good relationship with our HSM supplier. We have spares in them, we have SLA commitments on availability to parts, we have a long-term roadmap with them of survivability of this device. And so it's a commitment that's extremely serious for us because the integrity of our keying material is bound up in that relationship. As it happens, 2022 is when we will probably have to do a generational change in our HSM with the current vendor or potentially a new vendor. And so we're interested in seeing if during that generational change, we can move to a higher level of high availability, such as online redundancy for the HSM that's online, or a duplication for our offline trust anchor. But that's a bit of work in progress that'll probably span out over 2022, 2023. Now, that's quite enough from me. So if there's any questions any of you have that you'd like me to answer, I'm happy to help, but I would much rather that you ask Jeff and Frederick questions because they're more interesting than me.
Thank you so much, George. That was a really great presentation. And I'm sure that those who are watching right now might have further questions and are very much interested to continue the discussion. So I would actually like to invite all of you to the Routing Security SIG tomorrow. And that will be a little bit more interactive. It will be meeting mode, so be prepared to interact a little bit more. And perhaps from there, we could get more community feedback on some of the issues raised in this session today. So unfortunately, we do not have time for questions, George, so I hope you're ready to field them tomorrow during the SIG.
More than happy.
Awesome. So I'll have to wrap up the session right now. So thank you once again, George, and to all our awesome speakers, Jeff and Frederick. If you have any further questions, please feel free to forward them to conference@apnic.net. Before you go, though, we would like to trigger a poll just for you to tell us how you think the session went to help us improve the next time around. So while you're filling out that poll, I'll just let you know that we are having a 15-minute break. Make that 10 minutes because we ran a bit over time, a 10-minute break before APNIC's IPv6 deployment session begins. So thank you so much, everybody. We'll see you back here in 10 minutes for APNIC's IPv6 deployment session. Thank you all.